And now, let's answer this question together. Alright, so given this equation, our goal is to find the value of n that satisfies this equation. Alright, so to answer this question, what we're going to do is to get the first term. Let's have the first term 1 over n minus 1 times n minus 2. Now, what we're going to do is to look for some equivalent of this fraction. Now, let's try. How about 1 over n minus 2 minus 1 over n minus 1? Now, why we choose these fractions? Of course, the denominator must be n minus 2, and we have n minus 1. And of course, since they are different, what we're going to do is to make these two denominators the same. So the first fraction, let's multiply this by n minus 1. So we have n minus 1 on the top and n minus 1 on the denominator. And also, we have here n minus 1, so to make this the same, so let's multiply this fraction to n minus 2 over n minus 2. So if we do that, we get n minus 2 on the numerator, and we have a factor of n minus 2 on the denominator. Now, they have the same denominator, and this is also the same to our original fraction 1 over n minus 1 times n minus 2. Alright, so what we're going to do here is to simplify this. Now, they have the same denominator. We can now combine them. So if we do that, we get n minus 1 minus n plus 2. And surprisingly, we can cancel out positive n and negative n. So this is just 0. And negative 1 plus 2, this is just 1. And look at this. They are just the same thing. So we can say that 1 over n minus 1 times n minus 2 can be rewrite as 1 over n minus 2 minus 1 over n minus 1. Now, this is very important. So let's replace 1 over n minus 1 times n minus 2 with its equivalent value. All right. Now, how about 1 over n minus 2 multiplied by n minus 3? Now, using the same concept a while ago, we can say that this is equivalent to 1 over n minus 3 minus 1 over n minus 2. So you can check. If you simplify this, you get this result. So 1 over n minus 2 multiplied by n minus 3. So we can replace this with its equivalent like this. And on the last one, the last fraction, 1 over n minus 3 multiplied by n minus 4, this can be written as 1 over n minus 4 minus 1 over n minus 3. So we can replace this with its equivalent. Now, why is this important? Here's the reason. Because take note that we can cancel out 1 over n minus 2 right over here and negative 1 over n minus 2 right over here. Also, we have positive 1 over n minus 3 and negative 1 over n minus 3. So this simplifies to negative 1 over n minus 1 plus 1 over n minus 4. Now, let's focus on this equation and rearrange some terms a little bit. So we have 1 over n minus 4 minus 1 over n minus 1 equals 1 over 6. Now, they have the same denominator, so why not? Let's multiply the first fraction by n minus 1 over n minus 1. And the second fraction, let's multiply this with n minus 4. Now, we have the same denominator, n minus 1 times n minus 4, so we can combine these two fractions. And if we do that, we get n minus 1 minus n plus 4 on the numerator over n minus 1 times n minus 4 on the denominator. Now, again, we can cancel out positive and negative n, and we can combine this one, negative 1 plus 4, this will give us positive 3. Now, we are ready to solve for the value of n. So what we're going to do is to just cross multiply. So we have 3 times 6 equals n minus 1 times n minus 4. Now, 3 times 6 is just 18. And if we multiply this, we have n squared. We have negative 4n. Multiply negative 1 by n, we have negative n. So if we combine this, we have negative 5n. And we have negative 1 times negative 4. This will give us positive 4. So the right-hand side of our equation can be written as n squared minus 5n plus 4. So if you multiply this, n minus 1 times n minus 4, you get something like n squared minus 5n plus 4. Alright, now let's subtract 18 on both sides. And if we do that, we get 0 equals n squared minus 5n minus 14. Now, we can easily factor this because 14 or negative 14 can be written as negative 7 times 2. And this negative 5 can be written as negative 7 plus 2. So we can factor this as follows. We have n plus 2 multiplied by n minus 7. Now, let's rewrite this using its factored form. And now, since it is equal to 0, so we can say that at least one of them must be equal to 0. So we have n plus 2 equals 0, or n minus 7 equals 0. Now, using the first equation, if we subtract 2 on both sides, we get n equals negative 2. And on the second equation, if we add 7 on both sides, we get n equals 7. And there you go. We have two possible values of n that satisfies this equation. 1 over n minus 1 times n minus 2, plus 1 over n minus 2 times n minus 3, plus 1 over n minus 3 times n minus 4 equals 1 over 6. And there you go. We have n equals 2 or n equals 7. And as always, we are done.